Hello everyone. So today we will start with next synthesis of alcohols. The first one is Mewin-Pondorf Valley reduction, or shortly we can say MPV reduction, in which the ketone reacts with isopropyl alcohol in presence of aluminum isopropoxide. This is the catalyst which is used, aluminum isopropoxide, to produce a secondary alcohol and the respective ketone of the isopropyl alcohol. This reaction mechanism is now a little bit difficult for you because it consists of some methodology, which is cycloaddition reaction, transfer reaction, electron transfer reaction. So the mechanism is not necessary now. We'll study that later. Okay, next we will see the reduction of carboxylic acids. Reduction of carboxylic acid, in which RCH2OH, sorry, RCOOH is reduced to RCH2OH. The reagent is same, you can say plus 4H in presence of lithium aluminum hydride, LiAlH4. This is simple mechanism. We can say alternatively, we know that if we reduce in the same procedure, if we reduce this acid in presence of lithium aluminum hydride, this will firstly produce RC double bond OH. This will firstly produce aldehyde, and next, in presence of lithium aluminum hydride, this will produce RCH2OH. Okay, if we consider the mechanism, let's see mechanism. RC double bond OH. Okay. First, if this is lithium aluminum hydride, that means AlH3H minus. First step, hydride will attack this. Next, this will form O minus OH H. Okay, this O minus, this will be okay, no, sorry, okay, now it is correct. This will form O minus, and from the hydrolysis this will form ROH H. Two OH groups on a same carbon is unstable, that's why it will lose one water. There will be dehydration to produce RC double bond H, which is aldehyde, and this aldehyde will further produce alcohol. This is called the reduction of carboxylic acid. Simply we can say RCOOH plus 4H in presence of lithium aluminum hydride to produce RCH2OH. Okay, particular example like CH3COOH plus 4H in presence of lithium aluminum hydride to produce CH3 CH2OH. Okay. Next we will see the reduction of esters. Okay. In the same mechanism, we can say reduction of esters, like RCOOR dash in presence of lithium aluminum hydride, LiAlH4. This will produce RCOOH CO, so this will produce RCH2OH plus R-OH. Okay, if we consider the mechanism, let us see the mechanism. RCOOR. In the first step, lithium aluminum hydride AlH4 minus, so there will be attack of H minus hydride, and this will attack this. So there will be formation of RCOO minus CHOR dash. Okay, if there is negative charge, besides this there will be one positive ion. So this OR minus is a OR dash is a good leaving group. So this negative ion will come back, and this will be minus of R dash O minus plus R CHO. This is aldehyde. Okay, this on hydrolysis H2OH plus, this will produce R dash OH, and this on further lithium aluminum hydride and with further hydrolysis this will produce RCH2OH. Okay, this is the reduction of ester in presence of lithium aluminum hydride to produce alcohols. Okay. There is another method for the production of alcohol from ester, that is called Baumwold-Blank reduction. You can say BB reduction. In this reduction, the reagent that is used, the reagent is sodium and ethanol. The reagent is sodium and ethanol. If you see the reaction, C=OR dash plus 4H in presence of sodium and C2H5OH, which is alcohol, to produce RCH2OH plus R-OH. Two types of alcohol. Okay. In this we will see mechanism. The mechanism of this reduction, C=OR dash. Okay. So in the first step, okay, in the first step, there will be a transfer of electron. Transfer of electron from which? From sodium. This sodium will give one electron plus Na plus. Transfer of electron, this will C minus O OR dash, and this minus charge will gain one H plus from alcohol to produce RCHOR dash. This will next gain one electron to produce RCHO minus and OR dash. Now, as we have already seen, this is a good leaving group. This is a good leaving group. So this charge will get back. This will produce what? This will produce RCHO plus R-O minus. This will accept one proton from alcohol, C2H5OH, to further produce R-OH, and this similarly will further proceed and produce RCH2OH. We have seen in this previous video how this aldehyde will produce alcohol in presence of sodium and ethanol. Okay. Next, we will see the production of alcohol from alkenes. Alkenes also produce alcohol in presence of sulfuric acid. Like if you see RCH double bond CH2 plus H2SO4, this will produce RCHOH CH3. Okay, let us see the mechanism. This H2SO4 If you see this is an acid, so technically it will produce one H plus ion. So if you see this will produce one H plus ion along with HSO4 minus. Okay, or we can see that OSO3H, we can also call this as OSO3H. So if we remember the Markovnikov addition, it states that the negative part of the addendum will be added to the carbon with less number of hydrogens. So this negative part will be attached to this carbon. So there will be formation of, if we react RCH double bond CH2 with H2SO4, this will produce RCH OSO3H and CH3, because this is the negative part and this is the positive part. This positive part will be attached to the carbon with more number of hydrogens, and this negative part will be attached to carbon with less number of hydrogens. So this will produce this one, and after hydrolysis, or we can say H2O boiling, this will produce RCHOH CH3, production of secondary alcohol. Okay, next the production of alcohol from hydrolysis of ester. We have seen the esterification reaction. In esterification reaction, what happens? In esterification reaction, we mix one alcohol with one carboxylic acid in presence of acidic medium. This will produce one ester. And the hydrolysis of ester is the reverse process of esterification, in which there is hydrolysis of ester to produce one acid and one alcohol. Okay. If we see the general reaction, RCOOR dash plus H2O in presence of weak base, we can say, in presence of weak base like KOH to produce. If we directly react it with KOH or weak base in aqueous solution, it will produce RCO dash K plus plus R dash OH. Okay, let us see how this will react. Okay, let us see the mechanism. That is ester RCOOR dash. So as this is aqueous KOH, this will break to produce K plus ion and OH minus ion. This is nucleophile. So this OH minus ion nucleophile will attack to electrophilic carbonyl center. So this will produce R O minus OH OR dash. So as this is a good leaving group, this will be back, and this will be R dash O minus, and this will be RCOOH. Okay, if we write this separately, OH, okay, plus what it is produced, R dash O minus. Okay, this is acidic proton, as this carboxylic acid is an acid, so this is acidic proton. So this acidic proton will be easily available for bonding with this. This OH minus will attack this H plus, and this will produce R dash OH plus R C double bond O minus. Along with this minus, there will be attached a positive charge K plus. Okay, if there is further hydrolysis of this one, H2H plus, this will take H plus, and this will produce RCOOH. Okay, so by hydrolysis of esters, we can produce alcohol. The next step, we will see how you can produce alcohol from primary amines. We can also produce from primary amines by reaction with nitrous acid, like RNH2 plus HNO2 in presence of NaNO2 and HCl to produce ROH plus N2 plus H2. Okay, if you see, this reaction is generally in presence of aryl amines, or we can see in presence of aniline. This is diazotization reaction, production of diazonam salt. If you see this benzene, aniline, if we react with HNO2 in presence of NaNO2, HCl, this produces diazonam salt, N2 plus and Cl minus. This is a stable complex. This is a stable complex. Like benzene diazonam salt, BDC, we can shortly we say is BDC, benzene diazonam chloride. This is a stable complex. But in presence of aliphatic amines, RNH2 reaction with HNO2, this produces, let us consider this produces Rn2 plus Cl minus. This is an unstable complex. This is a unstable complex. So this will break down immediately to produce ROH plus N2 plus H2. So by this method we can produce alcohol from primary amines. Okay. Next we will see the procedure of production of alcohols using organometallic compounds. In the previous chapter, haloalkanes and haloarenes and organometallic compounds, we have studied that the best or well-known organometallic compound, that is Grignard's reagent. We have studied how can we prepare primary alcohol, secondary alcohol and primary, secondary and tertiary alcohol using Grignard's reagent. So we will see one by one all of this. First, we can produce primary alcohol by reacting Grignard reagent, or we can say, let us keep the heading, by using Grignard's reagent, which is general formula of Grignard reagent is R MgX. X is halogen, R is any alkyl group. Okay. Step by step we will see all the production. First of all, from formaldehyde. The formula formaldehyde HCHO. If we write C double bond H, if we react with one Grignard reagent, that is let us consider CS3 FgBr. Okay. In the Grignard reagent, the alkyl group which is attached to the metal that is negatively charged, or you can say this acquires partial negative charge and this acquires partial positive charge. So this alkyl group acts as nucleophile. So this will attack the carbonyl carbon, and there will be formation of CS3 CS2 O minus MgBr. Next, upon hydrolysis, this will produce CS3 CS2 OH plus MgOHBr. So in this method, there is production of primary alcohol using Grignard reagent in reaction or with reaction with formaldehyde. in reaction with formaldehyde. Next we will see how to produce secondary alcohol. Can produce secondary alcohol from previously we have used formaldehyde. Now we will use an aldehyde. The formula will be RCHO. If we react RCHO with R dash MgX and further by hydrolysis, this will produce RCHOH R dash. Let us see the mechanism. Let us consider this aldehyde RCHO. Let us react it with R dash MgX, or we can simply write, let us consider that this is C2H5 MgI. Let us react with this C2H5 MgI. So this part will be partially positive, this part will be partially negative. So this will act as nucleophile. So this minus will be attached to the carbonyl carbon and this will form. Let us consider this carbon. So firstly one R group is initially attached. Next to it one H group is attached. Next this R group is attached. Let us consider this is C2H5. Next to it O. This bond is now transferred to O minus. So this will produce O minus and MgBr plus. Okay. Next upon hydrolysis, this will produce RCHOH C2H5, which is secondary alcohol. Okay. So now we will see the production of alcohol from ketones. The ketones will produce tertiary alcohols. So let us see the mechanism, the reaction along with mechanism. Let us consider one ketone, that is acetone. So and consider this acetal will react with methyl magnesium bromide or CH3 MgBr. So as we already know, here this is the nucleophile. So this nucleophile will attack the electrophilic center and there will be production of CH3. There are already two CH3 group, two methyl group attached to the carbon and another one CH3 group arrives. There will be three methyl group attached to the carbon and O minus along with MgBr plus. Upon hydrolysis, this will produce tertiary alcohol. Three methyl groups attached and one OH group. So all of this discussed above are the methods for preparation of alcohols from different reactants and using different catalysts. In the next class we will see the physical properties and the chemical properties. If you have any doubts regarding this, how this mechanism is going on, or any other doubt regarding this, so you let me know in the comment section. Thank you.